Welcome back. So we've already seen that every instance of a class can have its own instance variables. So for example here, we have a point class, and inside of the constructor, _init, we can see that every point instance has instance variables for x and y to represent the position of that particular point. Now, for example, here when we create a new instance of point with x equal 2, y equal 3, then suppose that our point class is represented with this notation again. So this represents our point class. And P1 is an instance of the point class that has instance variable x set to 2 and instance variable y set to 3. Now, we also have another instance of our point class, so that's P2. And P2 has x set to 3 and y set to 12. All right, so we have P1 and we have P2. So one thing that I want to note is that instances have their own variables, but classes can have their own class variables. They work just like instance variables, except that they belong to the class itself. So for example, here, the point class has its own class variable called printed rep. So I'm going to write that inside of the class point, so I'll say printed rep. Is set to a star. Now, the point class also has these methods, which are also a form of class variables. So we have _init, and its value is some function. And we have this graph method, whose value is a different function. Now, whenever Python searches for anything of the form instance name dot instance var, so for example, if we're doing p1.graph or p2.graph, or even something like print p1.printed rep or print p1.x, then the search order that the Python evaluator goes in is it first searches inside of the instance. So in this case, if we're searching for p1.x, then it searches inside of p1 and it finds x there and it evaluates that to be 2. If it doesn't find an instance variable with the name x, or in this case, let's go with the example of p1.printed rep. So if we're searching for p1.printed rep, Python first searches inside of the instance p1. It doesn't find it there, so then it searches inside of the point class, and that's where it finds it. When we say p2.graph, Python first searches inside of p2. It doesn't find it there, and so it searches inside of the point class where it finds it. If we had something like print p1.z, then Python would first search inside of p1. It wouldn't find z there. It wouldn't find z there. It would then search inside of the point class. It wouldn't find z there either, and so it would give us a runtime error. Now, the way that we define this point class, if I erase these annotations, the way that we define the point class is that we have this graph method, and what graph does is it kind of forms a text graph, or a textual representation of a graph that contains this point. So if I erase my annotations and I run my code, so here I create 2 instances of point, one at 2.3, one at 3.12, and I call p1.graph, and what that does is it creates a little textual representation where here you can see kind of an x-axis, here you can see kind of a y-axis, and I can see that my point P1 is at 2. So 2 and 3, and I can see that my point P2 is at 3 and 12. Inside of this representation of graph, I refer to self.printed_rep. So you'll note that here, printed rep, again, is a class variable that's set to a star. If I change printed rep to be, let's say, a lowercase x, then you'll see that printed rep changes for both P1 and P2 when we actually call the graph method on both of them. So that's an example of how classes can contain variables. So again, we have instance variables that belong to every particular instance, and we have class variables which belong to a class. Here, technically, there are 3 class variables. There's printed rep, _init, and graph that all belong to the point class. That's all for now. Until next time.